So we are still continuing topic 2.1, and we're going to look at examples 1 and 2 in this video. These two examples, we might not see any like it in the homework, but we are going to start building towards what we're going to start seeing tomorrow. So we're going to be finding the slope of the graph of a linear function. Now, granted, you guys already know that the slope of this should be 2, right? We've seen that since Algebra 1. But what we're going to do is we're going to find it with this new formula that we have, which is the definition of a tangent line. Now, we've got some special notation, which we're going to put a name on this notation in a little bit here in the lesson, but we're going to call it f prime of 1. That's our special notation that's going to mean slope, okay? And I'm going to put it into this formula. So we've got the limit. I'm using this guy right here. As x approaches c, and our c value is whatever that x value is there. So that's 1 of, and I have to put in the function with the x. So I'm just going to do the function the way it looks. So 2x minus 3. And then I'm going to subtract, and I'm going to put a parentheses. And then I have to do the function with the c value plugged in. So 2 times 1 for the c minus 3 over x minus the c value, which is 1. And then I'm going to try to evaluate that. So I'm going to start by simplifying my algebra a bit. So I have 2x minus 3 minus 2 times 1 is 2, minus 3 would be negative 1. And then that's still all over x minus 1. My double negative is going to become positive. So I have simplifying algebra still. So I've got 2x and then 3 plus negative 3 plus 1 is negative 2 over x minus 1. And now we're going to go ahead and officially plug in that 1. So we have 2 times 1 minus 2 over 1 minus 1. I'm not going to officially plug that in because look at what I'm getting. I'm getting 0, aren't I? So I have to do a little bit more limit work, don't I? So I'm going to factor the 2 out of the numerator. So the limit as x approaches 1 of 2 times x minus 1 over x minus 1. Those cancel, and lo and behold, our slope is 2, which is what we expected. So that's a really long way to look at it in front of the graph and just say, hey, I know that's a line and the slope is 2. However, what happens if we are no longer linear? So now let's look at one that's non-linear. So we're going to do x squared plus 1 for still the value of x minus 1, which that is your c. So I'm going to write that fancy notation that means, hey, this is the slope of the line. So the limit as x approaches 1. Okay, so we're going to take our function with just the x plugged in, so x squared plus 1. And then I'm going to subtract our function with the 1 plugged in for the x, so 1 squared plus 1, all over x minus that c value again, 1. So we're going to simplify some algebra. So we've got x squared plus 1 minus 1 squared is 1 plus 1 is 2, all over x minus 1. And then we've got the limit as x approaches 1 of x squared minus 1 over x minus 1. And then I'm going to do some factoring because I can see already if I plug that in, I'm going to get 0. So it looks like I have a difference of squares factoring in the numerator. So I get x plus 1, x minus 1 over x minus 1. Those cancel. So I have the limit as x approaches 1 of x plus 1. I'm going to plug in my 1. So I get 1 plus 1. So my slope is actually equal to 2.